Hey guys, welcome. We're going to do page 12. So it says prove that. And let me just check. Oh, yeah, that one. There's one question from the other one. So let's see if I can fit 12 and 13 on the same tape. Prove theorems about parallelograms and use theorems about parallelograms to solve the problems. Theorems include opposite sides are congruent, opposite angles are congruent, diagonals of the parallel bisect each other, and conversely, rectangles are parallelograms with congruent diagonals. Okay, I would agree with all that, so let's dig in. Quadrilateral, so four-sided shape, is a parallelogram. Okay, so we've got some information here. This word means that these are parallel. And so we can look on our family tree of information and know that opposite angles of any parallelogram, like if this is 60, this is 60, and that makes this 120 because they're parallel, and that was 120. So opposite angles are congruent. Let's see how these are opposite. And adjacent angles are supplementary. And we know that about parallelograms, no matter what, because of how they're set up, creating these parallel angle relationships, same side interior angles. These are same side interior angles. So can we solve this little puzzle? Well, let's see. What is KSP? KSP. So what is this angle? We'll put an X there. Well, we don't know what this is. Or do we? In a weird way, we know that angle Q and angle P have to add up to 180, right? Because they're same side interior angles. So those add up to 180, so 76. And I'll call this y and y. So 76 plus 2y is equal to 180. Okay, so I get 104. So I know this whole angle is 104. So what would that make each of the smaller angles? Y would be 52. Okay, so this would be 52. This would be 52. Now we can focus on the triangle at hand. We've got a 52 angle. We have a 90-degree angle. And we can solve for x. So 52 plus 90 plus the angle x all add up to 180 because of the triangle sum theorem. So these would combine to make 142. And then I'm going to subtract that from 180. And we get 38. And what do you know? That's one of my choices. Question number 2. In the diagram below, this is a parallelogram. Okay. So that means these angles are equal and those angles are equal. And any acute added with an obtuse has to add up to 180. But they don't really care about the sides. They're talking, or the angles, they're talking about the side lengths. So we know any kind of parallelograms, opposite sides are equal. Two short ones, two long ones. Okay, so SV, we're calling our long one, has to be equal to, based on our picture, the picture could be off, but TU, there's my other long one. So I can set these equal to each other. Okay, so I'm going to subtract 1x on both sides. And we get this. And if I add 3 on both sides, we get dose. That's nice. So what's the length of SV? Okay, so let's see. We already know x is 2, so we can play, and we already know SV is x plus 2. So if x is 2 and plus another 3, I get 5, and that's one of my choices. Sweet. Now, question number 6, or 3. Given the parallelogram, DF is 5x. So we're given DF, this whole thing is 5x. What is XF? XF. Okay, so we know that in a parallelogram, diagonals bisect each other. And this is off of our family tree. We noticed all these observations. So if they give me the whole thing, DF, then bisect means to cut in half. So whatever that is, 5x minus 1, if I want to solve for XF, I know XF has to be DF cut in half. My problem here is I don't know what X is. So let's figure out what X is. This is also a diagonal that was cut in 2 equal pieces. So I can set these equal to each other and figure out what X is. So I'll subtract 2x on both sides. I get 1x, and this goes to 0. So let's add 5 on both sides, and we get x is equal to 5. Okay, beautiful. So now we can say DF is 25 minus 1, or 24. So now I can figure out if the whole thing is 24, then half of that would be 12. I didn't get that as my choice. Did I make any mistakes? I don't think I did. 5 times 5 is 25. Take away 1 is 24. Nope, I don't think I did. So I'm going to pick E, 12, and I think they got a typo. Question number 4. Using the same diagram as question 3, is EG perpendicular to DF? Where is EG meet this at a 90? So we know that from our family tree that diagonals are perpendicular if we have a kite. Right, these things. Or we have a rhombus, or we have a square. Right, so you see how these diagonals meet at a 90? These diagonals meet at a 90. Okay, so when would that be true? I'm going to have to say no, diagonals are not congruent. They are congruent. Oh, okay, I'm going to have to plug this back in to figure out. So, no, but that would be true in a parallelogram. So would they meet? So let's just do a regular old parallelogram. You see a regular old parallelogram, the diagonals don't meet at a 90. Like that's not a 90. So it says, impossible to tell, no side lengths given. Okay, that's what I'm going to pick. Because I don't know if this thing is like that or not, right? So, yeah, I'm going to pick that. All right, question number 5. It says, what is this angle, DAB? What would angle DAB be in order to show it's a parallelogram? Okay, so if it's a parallelogram, those are equal and these are equal. Does that make sense? So what measure would show that it was? So let's set Z. Let's set angle B and, oh boy, that was a weird thing. I must have put my palm down. Let's put angle B equal to angle D. So 2Z plus 15. Can't even see that, so let me try again. 2Z plus 15 is equal to 3Z minus 17. If we subtract 2Z on both sides, we get 1Z. And copy down this and that. Add 17 to both sides, and we get 32. Okay, So Z is 32. Now let's plug this in. Okay, so Z is 32. So angle B is 2 times 32 plus 15. And D should be the same thing. Let's go ahead and just be extra careful and check. 3 times 32 minus 17. So that'd be 64 plus 15, which gives me 79. This would be 96 minus 17, which would also be 79. Perfect. Okay, so I have a parallelogram that's 79, 79. So this angle here, angle A, would just be supplementary. So angle A and angle B are supplementary. They add up to 180 because they're same side interior angles. So if A is what we're solving for and B is 79, we can solve by subtracting it from 180. And we get 101. So what would that angle be? Angle DAB would be 101. And that one would be 101. Question number 6. Using the same diagram in 5, what of the values of x and y would show that it's a parallelogram? So what values x and y? Okay, so we solved for z. But x and y, we know in a parallelogram, we have 2 short ones equal, so we can set those equal. And we have 2 long ones equal, and we can set those equal. 2x plus 4y is equal to 3x minus 3. All right, so let's solve. And copy stuff down. So let's add 2. We get 5. So that would just be y is 5. Let's look for what x would be. But now we know y is 5. So we have 2x plus 4 and y is 5. 3x minus 3. Okay, so we have plus 3, I get 23. Well done. I'm just going to keep going and put video 3 because this is not a ton of questions, and this one's the same learning goal. Ms. Davis gave her students all the steps to approve. One step is not needed. Which step is not necessary? So given that this is a parallelogram, prove that this triangle is congruent to this triangle. So let's see what step is not needed. First, they said given. We need that. They said, well, what is it you're trying to spell? Let's see, side, side, side. So if you're trying to spell side, 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 you don't need any angle evidence. You just need 3 pieces of side evidence. So step 3 is not needed. It's true, but it's not needed to prove side, side, side. I just need side evidence to prove side, side, side. Okay. Next learning goal. It starts here on page 13, so let's dig in. It says, make a formal geometric construction with a variety of tools and methods: compass, straight edge, strings, reflective devices, paper folding, dynamic geometry software. Copy segments, copy angles, bisect segments, bisect angles, construct perpendicular lines, including perpendicular bisectors, and construct lines parallel to those. Okay, so we've done this all year. If I want to cut line GH in half, I make an arc from one, and I make sure I open it a little more than half. If I don't, the 2 arc marks won't cross. And then I do that again, and make a compass from H and open it a little bit more than half. And there you have it. Where they meet, we connect, and we draw that line. We end up getting a perpendicular bisector. What is the final step? We need a straight edge, right, guys? We need a straight edge to connect these 2 points. That's what we need to finish off our perpendicular bisector. Question number 2. In order to construct an interior point of CAB. Yeah. So interior point meaning I need a point somewhere in here, right? Because I'm trying to cut this thing in half, right? So if I'm going to cut it in half, I need to figure out where does this line go? so that I can cut this in 2 equal pieces, right? In order to construct an interior point for C, for the angle bisector, where should you place the compass? Okay, so you're going to place the compass on B and make an interior point, and then you're going to place it on C and make an interior point, and where they meet, you're going to connect those lines. So it doesn't, I don't like this. I'm going to say at B or C. You can pick either point to make an arc and then make an arc. But normally you would just go alphabetical. So you would pick B, place the compass at B and make an arc. You just go in alphabetical order. Then place it at C and make an arc. Make that new point D, and then use a straight edge to connect AD. That's the rest of the steps. Cool. All right, question number 3. It says select all the statements that describe the steps to copy XY. So I'm just going to go through those steps, right? To copy XY, step 1, you want to use a straight edge. So just make a straight line anywhere. And you want to copy a point. Doesn't matter where. So take a ruler and draw a line and label that point M. This step is step 1. That's kind of what I've done there. Oh, wait. I fell for that trick, didn't I? I don't really need a ruler. I just need something straight. Okay, so I've done this. This is my step 1. Then it says, place the compass at X and open it the length. So we use the compass as a measuring device and open it. Yep, I'm going to do that. I think that's step 2. And then in the same setting, place the compass at M and draw an arc that same length. So you see how you're copying this length over here to there. So I like that. And draw an arc through line L. This is our line L. So I like that. And mark it as point N. Yep, so that sounds like my step 3. Then it says, then I've done it, right? This segment got copied here. This last one says, with a setting greater than 1/2 of XY, place the compass back at X. This is a step from this one. This was what I wrote here. This is a step from my perpendicular bisector, not copy of a line. So let me write this in. A ruler, don't need, right? Because I'm only using it to sketch a straight line. I'm not using it to measure. Well done, all. See you next time.